But what problem do we solve? When you have a bone defect to the face following a trauma or a cancer, for example, usually the surgeon has to remove a part of your bone. He has different solutions to replace it. He can use plastic like pig, titanium, or granules, but usually they prefer to use autografts. Autograft is when the surgeon takes a part of the bone somewhere else in your body, then shape it the best he can, and then place it in your face. Obviously, surgeon likes autograft because it's natural bone from the patient. It's therefore a long-term solution and very biocompatible solution. But autografts has many risks and also limitations. One of the first is the psychological sequelae. You can see on the right a picture of a patient who underwent this type of surgery. She had a bone tumor to her face, and the patient took a part of the bone of her leg. You can see that the facial symmetry was not completely restored, and she had to live like this now. She also has physical sequelae. You can see the scars on her leg, and she also had to go to a lot of rehabilitation to be able to walk. The surgery to perform autograft is a very time-consuming surgery and also highly expensive. And I would like to remind you that 1 minute of surgery costs between 60 to 100 euros. The rehabilitation is also very long and very costly, and since it takes time and a lot of physical therapy. At Cerhum, we wanted to find a solution for this patient and an alternative to autografts. To have a good and working solution, we wanted to have a long-term material and an efficient material. We wanted to give the patient the perfect aesthetic outcome, and to the surgeon, we wanted to provide them with a fast surgery. We also wanted to have a faster revalidation for the patients and overall a lower cost for the social security. And we found this solution. We call it MyBone. So what is MyBone? It's a 3D printed bioceramic. For the ceramic, we use calcium and phosphate. It's the same composition than the bone mineral. There is a long history of scientific publication and clinical trial regarding calcium phosphate ceramic. Therefore, the safety and the long-term proof of this material is already available and demonstrated. We have based the design of MyBone according to more than even 400 meetings with surgeons. This solution is on the market. We have everything to manufacture it, and we are compliant with the MDR. But what makes MyBone unique and what makes it different to our competitors, it's its patented design. To have a good bone reconstruction, the key is the vascularization. With conventional solution like granules on the left, there is very little space for blood vessels to grow. They have to find their path between those granules, so it takes time. With MyBone, we wanted to change that, and we have decided to provide highways for the blood vessel. And this is possible thanks to the optimized porosity that we confer to MyBone. The blood vessel can go fast and very deep into MyBone. Here is a short video presenting this concept. You will see the good hydrophilicity properties of MyBone when you compare it to XENOGRAFT. XENOGRAFT is conventional solution used by maxillofacial surgeon. You can see on the right MyBone. When it enters in contact with the fluids, it goes very fast, very deep into MyBone. Therefore, when you have nutrient or body fluids in contact with MyBone, they can go very fast and colonize the bone graft. But how do we make it? We start with the patient scan. Based on this data, we are able to design a patient-specific bone graft that you can see here. We use a web-based platform to discuss the 3D planning with the surgeon, and he can give us comments on the design of the bone graft. Once we agree with the surgeon regarding the design, we can 3D print this part. We use VAT polymerization technique and stereolithography. Several layers several layers of paste. Several layers of paste are spread on a platform, and then a UV light is used to harden some specific parts. The paste that we use is composed of calcium phosphate powder and also chemical compounds. You can see here the UV light. Once it's done, we have to remove the extra paste, and so we clean the part and remove all this extra paste that was not hardened by the UV light. Once the part is completely clean, here, we will place it in an oven. In this oven, there will be a thermal treatment that will last for a few days. The first step of the thermal treatment is called the debinding. During this step, all the chemical compounds will be removed. And then the second step is called the sintering. During the sintering, all the ceramic grains that are in the paste will fuse together and create a hard part. Then we will control the implant that we have manufactured thanks to a 3D scan. We will then compare the design that we have obtained with what the surgeon required at the beginning. The final step will be then the packaging and the delivery to the hospital. Once it arrives at the hospital, they perform the sterilization, and then it can be used during the surgery. We wanted to have a simple procedures for the surgeon because we know they don't have a lot of time. So we have a web-based platform on which they can directly upload the patient images. Then Cerhum's engineers start to work on these images. They create a 3D model of the patient and also prepare the design of the implant. On the web-based platform, the surgeon can review the design and makes any comments he wants. Once there is a validated design, we 3D print and then deliver it. It's then very easy for the surgeon. What are our preclinical proof? We have performed more than 300 surgeries. They are spread over 8 studies on animals. We have demonstrated several concepts. The first one is the functional vascularization. As I told you before, vascularization is key to have a good bone reconstruction, and we have optimized the porosity of my bone to perform a fast vascularization. And we have demonstrated this in our animal studies. After only a few weeks, this is already functional. We have also studied the bone ingrow and its quality, and we have shown that we have a faster bone ingrow, up to 7 times faster, and also higher quality compared to the new bone that is formed in conventional material. Finally, we have studied the material for dental implantation, and we have shown good success of dental implant placement into my bone. In this study that was performed on rats, we have compared my bone with granules, which are conventionally used by a surgeon, but we have also compared it to conventional 3D printed parts. Those conventional 3D printed parts do not have the optimized porosity that is present in my bone. We have looked at the bone ingrowth at 4 weeks and 8 weeks, and we have seen that there is a higher quantity of bone at 8 weeks in my bone, up to 7 times more bone into my bone already after 8 weeks. Then we perform another study. We wanted to analyze this new bone more quantitatively and qualitatively. We have performed a study on sheep, which lasts for 6 months. And we have looked at the new bone that is formed into my bone, and also the one that is formed in conventional solution, in the gold standard product. And the results are very good. For my bone, already after 4 weeks, we have higher osteointegration. But that's not all. We also have a higher quality bone. We have seen that the new bone that is formed into my bone is more mineralized. And we have also seen higher level of bone marrow. All of this already after 4 weeks. But we want to go even further in the bone reconstruction and try faster solution. And we have studied my bone with stem cells. We have demonstrated that only when putting the stem cells in contact with my bone, they spontaneously differentiate into osteocytes. This is going to be a key result to find even a faster solution to have bone reconstruction. But we are not a preclinical company anymore. We have already strong clinical evidences. First, regarding the maxillofacial area, we have delivered more than 33 implants now, and we have a 100% success rate on our current commercial focus. The follow-up goes up to 4 years for those maxillofacial reconstruction. We also have a background in spine reconstruction, spine surgery, in which we have seen high fusion rate already at 3 months with our 3D printed product, but this is not the topic of the day. And also, we are spreading the use of my bone to more dental focus reconstruction, and we have our first successful case. In my bone, we were able to place 2 dental implants, and we have a 14 months follow-up on that patient. So go back to the maxillofacial bone reconstruction. Here you can see different design of bone reconstruction. All of these are patients that we have treated with my bone. You can see that my bone is a very versatile solution, and it can be used to replace osteotomies, PEEK, also titanium, granules, etc. It can be used for rhinoplasty, zygomatic bone augmentation, but also mandibular bone augmentation. We have also performed orbital floor reconstruction and genioplasty. I will give you a little bit more detail on a specific case. This is a trauma case. The patient had a bone defect on a maxillary bone due to a gunshot. To reconstruct this space, we have 3D print the piece that could easily fit the defect and fit it like a piece of puzzle. The surgeon stabilized the part, the ceramic part, with 2 screws and obtained a good stabilization. We have a 6 months follow-up on that patient. You can see the 2 CT scan on the right. When you compare those scans, you can see signs of osteointegration. The bright part is my bone. And when you look at the edges of my bone, you see that new layers of bone are growing in contact with my bone. This is demonstrated that osteointegration is working. Last year, we have also performed a world premiere in France. This is a patient that had no nose anymore. Over 10 years, she had to live without a nose. Surgeon tried different surgery, they all failed. And then they had the idea to use my bone to reconstruct her nose. We 3D print the nose. You can see on the right image in the hand of the surgeon. And then the surgeon placed the nose, the 3D printed nose, on the arm of the patient into this arm and left it for a few weeks. This gave time to the blood vessel to grow into my bone and colonize it. And then the surgeon took this vascularized my bone and placed it on the face of the patient. This was very game-changing for the patient. She was very happy with the result. She is now going out of her home because for 10 years, she was really ashamed of her face and she was only living in her home. Now she is looking for work. She can also smell odors because previously she couldn't. Now she can cook and smell the odors of what she is cooking. So we have different KOLs and reference centers working with us. They are spread over France, Belgium, and Netherlands. The KOLs are really a strong pillar of Cerhum. We are really working closely with the surgeon to improve and develop my bone because they are helping us to spread the use of my bone in this fast growing market. These surgeons and KOLs are also working closely with us to provide high quality proof of my bone. If you are interested to use my bone or if you want to work with us, don't hesitate to contact us. And finally, I would like to present you the team behind the curtains. We are a very united and talented team composed of people with complementary skills. Here we are Cerhum. Thank you, everyone.
Thank you, Elizabeth. Yeah, thanks for the, oh, hey guys, give Elizabeth some kudos here. Yeah, it was an amazing presentation. Cerhum has done amazing work in the space. And I remember seeing that viral nose post on social media. And it's incredible that what you guys are working on. We have quite a few questions here. Since you're the regulatory clinical affair officer, what quality and regulatory considerations are needed when 3D printing bone prior to implantation?
I would say you have to be imaginative because it's a new type of process, new type of product, so you cannot find any guidance in current standards or regulatory documents. So you have to work really with what you found, but keep it simple and try to have a good quality and document everything. It's always the same process, but it's new product, yeah.
Yeah, and also for you guys, you know, MDR, right, is what you have to work with as opposed to FDA. Are you guys going through FDA clearance as well?
We have started the FDA process, but we start with standard products. So those products are not patient specific, but that's the goal. We go step by step with first standard product, and it's on the way. But yeah, with the MDR, that was a bit more complicated, right. But we could find a way. We are really discussing the design with the surgeon, and this is a custom-made product, but we have to document very carefully what we do.
Yeah, I'm actually surprised that you guys started with MDR first, because a lot of medical device companies basically just avoid it altogether because the new ones are so complicated and annoying. That's my understanding.
Yeah, but we are a Belgian company, and we have surgeons very close to us, very motivated, and they are really giving us motivation to keep working and be on the market in Europe. So that was driving us to be on the market in France, Belgium, and Netherlands.
All right. Okay. So guys, if you want to have Cerhum bone implant, go to these countries. All right. So we have some other questions from Pasek Powell. Is how much time, because you say you have to incubate these or oven thermal treat these for days. Like, what is your, okay.
Yeah, the thermal
will be like the cost of compared to a regular implant, time and money, like compared to regular.
So the time typically in the oven, it's between 3 to 5 days, but the overall process we can do it in 2 weeks with when you have an urgent case, and depending with the condition of the patient, 10 days to 2 weeks. That's the fastest currently, but we have solutions that we are working on to go even faster. And regarding the price, it's a bit more expensive than, for example, PEEK implants, but it's very similar to patient-specific titanium implants. It's higher quality material, a bit more expensive at the beginning, but if you look at the long term, it will be cheaper for the social security because you can keep it for your whole life. So PEEK implants, that's a great possibility that people will have to do a revision surgery, not with our material. So we are working to prove that to the authorities and get reimbursement.
Mm-hmm. So do you have, you don't have clinical outcome studies comparing these different materials yet, right? Like comparing titanium versus PEEK? No, we do not have yet clinical studies comparing this. We are preparing one to compare with autografts, but not with titanium and PEEK. Yeah, if it's comparable with autograft, then that's definitely better.
That's it, yeah.
Exactly. All right, so another question from Gupu Cerhum. He said, excellent results in terms of osseointegration. Can my bone undergo remodeling over time? Based on what that's experienced?
Yeah, so it depends of the type of ceramic we use. We can use hydroxyapatite, which is a very stable ceramic, so it will stay in the patient body for a long time. But we can also use another type of ceramic, which is called tricalcium phosphate, which resorb much faster and can therefore remodel with the bone of the patient. And we can do a mix of both. So we can really fine tune the remodeling and how fast it's going to resorb.
And what kind of condition would people want a fast resorption? And then what kind of condition people just want it to be in there forever?
In the maxillofacial area, usually surgeons prefer hydroxyapatite like we do, which is a more long-term material, because you want to have a good structure and not to have it to resorb too fast. So usually they go with hydroxyapatite, but for orthopedic indication, surgeons try to go more with the resorbable solution that's going to be fully replaced by bone in a few years.
Okay, I think that answers